Okay, let's flip over and talk a little bit on page 9. So now we've talked about being careful not to create bias. That was last time. Now we just talked about all the different types of data we could collect. We'll be talking fairly soon about your project. I told you there'll be a project this semester, and you're going to go out and collect data, and maybe you're going to get some categorical and some quantitative data. So you might be asking people their favorite movies and their heights, or how much money they make, whatever it might be. How you collect the data, you have some options. One of them is that you could just go out and do what we call an observational study here on the top of the page. You just go and you observe whatever it is you're looking for. Every semester I have someone who chooses to do their project on cars. And I once had a student who went out here and stood on the corner and just counted. This is how many blue cars went by, this is how many white cars went by, this is how many trucks, this is how many SUVs. I don't know if it was the most interesting project she came up with, but that's what she wanted to do. The point is, she was observing. She just stood and observed whatever her sample was going to be. So her sample was the cars that happened to drive by that morning between 9 a.m. and 10 a.m., whenever it might have been. So she was doing an observational study, just watching, looking, and recording what she saw. She wasn't interfering with the cars. She wasn't, jumping out on the road. Hey, stop! Let me ask you a question about your car, right? Let me tell you something and then get some information. So observational study is just observing. Whether you're actually observing with your eyes, or you're looking up some data online, or you're handing out surveys and getting information back, you're just observing. You're not interfering with it in any way. The other way is an experiment. Typically this happens all the time in science. Some of you have had science classes before, where some treatment, they call it treatment, is applied to the subjects. The person or group does something to affect the outcome. So let's say I think I've got this new drug that's going to help cure cancer. I really wish I did. I'm going to take this drug and this, what we call a placebo, something that really does nothing, but you can't tell the difference when you look at them. And I'll administer one drug to some people and the placebo to others and see if there's any difference in the results. So I've now deliberately affected my results by putting people into one group versus the other group. So I've applied some treatment now. So now I'm not just observing, I'm doing an experiment. I had a group once who did their project on dogs. And they wanted to know, one of the girls worked at a vet's office, and they wanted to know how they spoke. It was actually next group. How they spoke to the dogs, if it affected how the dog reacted to them. So if they came in and were kind of rough to the dog and spoke kind of harshly, how would the dog react to them versus if they were very sweet and kind and gentle with the dog. So, and it was like every other dog, they would go through and speak to it differently to see how the dog reacted to them. So that, again, was an experiment because they were doing something to affect the outcome, as opposed to just checking to see how each dog acted when it came in. That would have been different. Clear the difference there? Depending on what you're trying to find out, you might do one versus the other. Okay, these next two things on the list here, simple random sample and random sample, take 2 minutes to read them, and then I'm going to discuss them. And these are two of the hardest things for anyone to wrap their brain around. So read them first, I'll shut up, and then we'll talk about them. Reactions? Who thinks they could explain the difference between those two things? Ooh, silence. Stephanie. You think you could? Maybe. Ooh, I like a maybe. Is there anyone who thinks they sound pretty much the same? Is that your hand up? Yeah. They sound kind of the same, don't they? They're almost the same. And this is why this is one of the hardest things for stat students to get. I work in the lab so many hours every semester, and even if it's not my students, this is the most common question I get in the math lab. It's, Jill, I don't know if this is a simple random sample or a random sample, and I still don't think I know the difference. And I spend all day for the first couple weeks telling people what the difference is between those two groups. Is your hand up?
Isn't simple just like out of a sample instead of a population?
Both of them are samples. So both of them are you're collecting a sample out of your population. So let's say we have all LMC students and we want to collect a sample of some LMC students. So then the question is, once you get that smaller group, is it a simple random sample or just a random sample? We're going to talk through it, don't worry. I'm going to use an even smaller population from our discussion today. So let's assume that you guys are my population and I want to select 4 of you. That'll be my sample of size 4. Okay? So we want to discuss what it means to be a simple random sample versus a random sample. We're going to talk about simple random sample first. If I take all your names, I put them all into a bowl and I mix them all up here, I got my big giant bowl here, and I reach in and I pull out 4 names. Let's talk about that. It says here, a sample of n subjects. I chose 4. N was my 4, right? My 4. We're going to have a sample of 4 subjects that's selected, so every possible sample of the same size, 4, has the same chance of being chosen. So I'm going to reach in here and pull out 4 names. Is it possible that I'll happen to get these 4 people who happen to be sitting in the front of these rows right here? Could I get all 4 of these? I could. Am I just as likely to get the 4 people that are sitting in the back over there? Same chance, right? Or maybe I'll get 1 from over here and 2 sitting next to each other in the middle and 1 over there. There's no group that's more likely to happen than others. We agree? If I just put them all in a bowl and pull them out? That's the best way to think of a simple random sample, is imagine if you put everybody's names or numbers into a bowl and you pulled them out. Is that what you're doing? A lot of times the description may not say that's what we're putting it into a bowl, but the description is very similar to comparing it to that. That's what makes it a simple random sample. Every possible group has the same chance of being selected. Those are my words to go along with the specific definition. So what about random sample? How's that different?
Because it's individual. Like the last one we were talking about a group, and this one says individual member from the population.
Right, so each individual has the same chance. Okay, so let's talk about that. In my example of the bowl, do you all have the same chance of being chosen out of my bowl?
Yeah.
Yes. See how they sound the same? So the simple random sample that we just discussed is a random sample. Random is a little bit looser. It's a very specific one. If I pull names out of a bowl, you all individually have the same chance of being selected. But also every possible group could come out of my bowl. So it was a random sample, and in more particular, if I use my bowl, it's a simple random sample. I'll give you an example of something that's random but not simple random to help you see the difference. Imagine for the moment that every row has 4 people in it. There's 10 rows here, say. 4 people each. I'm going to use my little random number generator on my calculator, and I'm going to pick a number, and my sample's going to be everybody in that row. Do you all have the same chance of being selected? If there's 4 in each, pretend there's 4 in each, otherwise it doesn't work. If there's 4 in each row and I pick a number between 1 and 10, is there anybody here who's more likely to be chosen than somebody else? No, right? Because I'm just as likely to get this row of 4 than I am to get that row of 4. You're not sitting over here going, oh great, my chances just went down. Every individual person has the same chance. But will I ever get a group with these 4 people in it? Not doing that technique, right? Because I'm taking a whole row. Either I get this row or I get this row. These best friends forever are never going to be in the same group. So it's random because every individual has the same chance, but not every group could happen. That's why it's not a simple random sample. I need someone to ask me a question now. If you don't ask me now, you're going to be asking when you start doing your homework. Because everybody in the lab asked me this question. Yes?
So just to be clear, the simple random sample is more about a group, a selection of a group size, and then the random sample is individual chances of being selected.
You're correct, except that the simple random is also random. So in a simple random sample, every individual has the same chance, and every group has the same chance. So you're right, it is more about the group, but it's not ignoring that first part. Random just means every individual, and simple random means every individual and every possible group. Does that help?
Mm-hmm.
Other comments or questions? I see some of your heads spinning like, I still don't get it. We'll beat it up till we're sure we're kind of getting it. If I gave you a list of a whole bunch of scenarios and asked you which ones were random and which ones were simple random, do you think you'd be able to tell the difference? Yes.
So simple random sample has to have 2 criteria.
Yes, I like the way he says that. 2 criteria for simple random. Every individual has to have the same chance, and every group has to have the same chance. That's what makes it simple random sample. And the best way to recognize it is, can you compare it to putting everybody into a hat and picking some out? Because once you mix them all in there, every possible group could come out. Once you do something to lump people together, like I put you in rows, all of a sudden you've restricted the groups. And that's how you can tell it wouldn't be simple random anymore. Yes?
So like a random sample is like getting a bunch of like sandwiches and like putting in a bag, taking a random sandwich, or like a simple random sample is like every ingredient in a bag.
Say it again for me, please.
It's like, so a random sample would be like putting sandwiches in a bag and picking one out, while a simple random would be like ingredients in a bag.
Okay, I like what you're saying, but we have to clarify it a little bit. So he's saying if you already make sandwiches and put them in a bag versus if you put the ingredients in the bag. So let's say, but your sandwiches all have to all be different. That's the thing. That's what. So let's say you have one sandwich that's on sourdough and it's peanut butter and jelly. And then you have another sandwich, I'm making these up. Then you have another sandwich that's on wheat bread and it's got ham and cheddar. And then you have another sandwich, I don't know, it's on something else. So then if you randomly pick it, you can't get sourdough with the ham and cheddar because it wasn't made that way, right? So that would not be a simple random. But if we had just thrown the ingredients in and reached in there, you could get the sourdough with the ham and cheddar because they weren't pre-made, right? The only problem with the ingredients, though, is my sandwich might just be sourdough, wheat, and white bread and nothing else, which wouldn't be the best sandwich. But that's the idea, is it's whether it's already pre-grouped together or everything's loose like that, and you could get every possible combination. Somebody else might get a sandwich that's just cheese and peanut butter, which would not be good either. But hey, no bread, just cheese and peanut butter. That was a pretty good analogy. We had to make sure we recognized that they were all different. Other comments or questions about that one? This is the hardest thing to really own. Always go back to, I like the way we're discussing this, 2 criteria for simple random, every individual and every group, and it can be compared to pulling names out of a bowl. Okay, before we go on to the rest of it, I'm going to go ahead and take our break now. I want to figure out what the computer issues were with a few of you. A couple of you had add code issues. So we'll take a 10-minute break from here. We'll come back and finish talking about 1.3. I want to show you a little bit about how to access your homework. We showed you last time, and now most of you have gotten that far. And how to get to the textbook if you're trying to read the textbook online. I've had a couple questions about that. This paper tells you a lot of things. On the first side, it says navigating within my stat lab. This side tells you how to get into my stat lab. You actually don't have to go into the course at all if all you want to do is homework. You can just click on the links from Canvas. But if you want to read the textbook, if you want to do some extra quizzes that the publisher has made up, if you want to do some extra practice, there's all kinds of things here that you can find. I'm going to show you how to get in there. Apparently not. So once you sign into Canvas, I think it'll let me do it with mine. We'll find out. I changed my password yesterday and my brain can't handle it. Okay, where are we? This is awesome. So once you log into Canvas, it looks something like this. Does that look vaguely familiar? Yeah. So you could just start clicking on these assignments here to do your homework. Assignment 1 coming up. My favorite is to go over here to syllabus. Because when I click on syllabus, it just makes it look prettier. There's a calendar, and here's everything that's due on Monday. Here's everything that's due next Wednesday. And so from here, you can just start clicking on a homework assignment. But let's say I'm not ready to do my homework. I want to read the textbook first. Jill said to read the textbook before class. I want to read the textbook. We'll do the homework in a minute because we're all overachievers and we're going to read everything we need to. To access the textbook is a little bit different. It actually says right here at the top of the navigating my math lab, it says to go to My Lab and Mastering. That's over here, right underneath syllabus. Right here. When you click on My Lab and Mastering, it takes you to this page. It has all kinds of different links. You want to come all the way down here to Student Links and select My Stat Lab Course Home. Warning, it just happened to us and it happened to somebody else. Your computer most likely will block pop-ups, so if you don't watch up here to see if the pop-ups were blocked, you have to allow the pop-ups or it won't open this new page here. Once you get to this page, it takes you to what's called the My Stat Lab homepage. It's as if it doesn't care if you have Canvas or anything else. Before Canvas was used at this college, we went straight in this way. I fixed it already. So this is what the homepage looks like for My Stat Lab. But all these things over here on the left are what I'm referencing on this page here. So the homepage is where I am right now. And it even has what to do next, just like it did on Canvas, so you can click on those. But more importantly, you have the e-text, which is where you're going to read your textbook. If I click on this, it's going to take a while to load, so I'm not going to click on it. But if I click on this, it will open the textbook starting right from page 1. Instead of e-text, though, I prefer chapter contents because it takes you directly to the section that you want. So if I click on chapter contents and chapter 1, and I want to read this section 1.3 for next time, I'm going to click on just the section I want and choose e-text over here. And then it will take me directly to the first page of section 1.3 so I can read that section before class next time. The first time, oh, then you have to have your Flash player updated. And I can't do it because it's not my computer. If you have your Flash player updated, the textbook will load and you can just flip through the pages. Can't show you on this computer, sorry. But the most important thing is that to get to the textbook, you have to click on that My Lab and Mastering link and then the course home to get to that page. If you're not reading the textbook, you're reading it in the math lab, or you bought the physical textbook so you don't need the online textbook, you can do everything right from your Canvas page. I like to start at syllabus because I think it's prettiest. And I would just come in here and click on this first homework assignment, section 1.1. Most of you already done it. I saw that. That was great. It opens this up. It shows you your score. Look, I've got 1 point so far out of 12. I've scored 1 out of 12. And I got it wrong. That's what the red X means. So clearly I need to keep working on my homework. So on the back side of this page, it says to complete homework. So once you click on the assignment, you're in here. The first thing I'm going to do is start on question 1. I click on question 1. It takes me to the exact question. This is a horrible computer because that doesn't have all my help here. But so I read it and I can choose one of these and select the appropriate box and so forth. If I need some help with this question, because I'm confused, my notes aren't very good, maybe I was sleeping in class, not recommended. I can come up here to question help, and I could choose the textbook, which would take me right to the textbook for this section, so I could read it for reference. I can't show you that right now because my Flash player is outdated. I could ask my instructor. Ask my instructor is one of my favorite ones because everybody, well, not this problem, but once we start having numbers in our problems, everyone's problem is actually a little bit different. So yours might say, find the median for this list of numbers, and your list is going to be different than this person's list, so I can't help you referencing that without seeing your problem. So when you click Ask My Instructor, it sends an email directly to me with the exact link to your problem, so I know what your numbers are, I even can see what answer you put in there. So you can email me and say, hey Jill, help me out with this. I tried this and that, and I'm telling me it's wrong. What am I doing wrong here? So you can always email me directly as well. Later on, when there's more computation, in addition to these options here, there will be help me solve this. There's nothing to solve here. And it will actually take you step by step into all the little things you need to get there. So you can have all of that while you're working on the homework. So all of this is listed on all the options that you have here. Help me solve this, click in the textbook, ask my instructor. But the best thing is I can get this wrong. I have to make sure I get it wrong. And I check my answer, and it tells me I'm wrong. And so I have to read again. And then I'm gonna make sure I'm getting it wrong. If I keep getting it wrong, eventually I'm gonna do my final check, and it says, look, these are your answers, but it should have been B. But now I think I understand it finally, so I want to try the problem again. So at the bottom here, oh sorry, now I have to go ahead and answer some more questions. Darn it, it's a two-part question. Let me see if I get this part right. I have to read it real quick. Let's see. Nope. I didn't read the whole problem. I don't know why it's not entering, but I'm not going to read the whole problem. Let me get it all wrong. Okay. So at this point, I got that part wrong too. Oh, there you go. I didn't look at the whole thing. Should have been D and D. I only answered E. So it tells me what it should have been. And I can go on to the next question, but I just got that last one all wrong. So I can keep doing my homework. Let me go back out of here for a second. Got too many windows open. If I go back to this page, look at it. It'll show you that I got problem 1 wrong still. But I want to redo it because I think I understand it now and I want all the points. The thing I tell my students about homework is that you technically have no excuse for not having a perfect score on every homework, because every problem you can redo until you get it right. So why wouldn't you keep doing it until you get it right? Not only are you going to get the points, because most of us are about the points, but you will also learn what you need to learn so that when the test comes, you know how to do it. And so I tell people, if you have any red X's, if it was half right and half wrong, I'd have a green and a red, and she'll be part right and part wrong. But you can always click again right here. I don't. There we go. Oh, it went back to this page. So I can go down here and now I can click try again. So I got this part. It tells me what the answers should have been, what my answers were. So now I can click try again. It's really the same information again. The things are out of order. When it's multiple choice, it's almost too easy because you just have to remember the right answer. But later on, you're going to have to punch in some numbers, and you can't just guess. There's an infinite number of numbers there. But so this page tells you how to get to the textbook, which is important for a lot of you, and then all the options you have in your homework. I highly recommend you redo every problem in your homework until they're right. I can't force you to, but wouldn't it be nice to say, hey, I have 100% on homework? And the tests are not as easy as the homework, and you can't keep redoing them. So it's better to cushion your grade with the homework score than not. And you'll be more ready for the test, I'm telling you, if you keep working through that. So questions on this handout? Or how to access that online? Everyone who was having issues, we think we resolved them, right? I think we're good for now? All right, let's talk a little bit more about statistics when we get out of here. Clearly I have to finish my homework. If you noticed, there are 3 homework assignments due on Monday. The one we did last time, section 1.1. So section 1.2 that we just finished talking about, the categorical versus the quantitative. And then the 1.3 that we're working on right now. So everything that we'll have talked about up through the end of today is all due on Monday. Okay, 3 assignments. All right. What am I doing with my notes? So we left off about simple random sample versus random sample. Anybody have a follow-up question on those? You asked me again in the lab, that's okay. All right, so then there's sampling methods, how you get your sample. So say I wanted to get my 4 out of this group again. I want to sample a size 4. There's a lot of different ways we could do that. Some are more effective than others. The best case scenario is to have a simple random sample. best case, but simple random samples are hard. For this group, it wouldn't be so hard. There's only 40-ish of you, so I could put your names in that really easy and pull them out. But if I'm looking at the entire population of the US, getting a simple random sample out of all those people would be pretty challenging. Right? I mean, how am I going to do that? Take my whole population, but everybody, you know, I don't know, some people don't have, what if I use social security numbers on a computer? Maybe that would work. Some people don't have them, some people have two. Some people are, you know, it'd be too time consuming. So there's a lot of different techniques we use to get decent samples. One of them is called systematic. This is the easiest one, I think, to understand. You pick some starting point and you pick every kth. And the k just could be any number. Like I'm going to pick every other person or every third person. You know, so maybe I'm going to roll this invisible die I have here and it comes up to be a 5. So I'm just going to go along and count every 5th person's going to be in my sample. 1, 2, 3, 4. Okay, she's in my sample. 1, 2, 3, 4. Okay, now I've got her. I'll just keep counting, and every time I get to 5, that person will be in my sample. Is that random? Does everyone have the same chance of being in my sample? If I do that? If I pick every 5th? We didn't know it was going to be a 5 in advance. I see some yeses and some nos. And some I have no clue, Joe, what you're asking. Are you saying yes, or you're with that you have no clue? You think it is?
I think you have a good chance. Like everyone has the same chance because you didn't select the rule beforehand. You didn't organize students in a way that would benefit your sample.
Yeah, I didn't really organize you in any way. And before I roll my die and happened to get a 5, you didn't know what number I was going to roll. So I could just as easily as I'm counting through here land on this student as I could on her. I mean, you don't know. So everyone has the same chance. Once I pick the number, obviously that changes because it depends on where you're sitting. But it is random, actually. Systematic is random. Because once you pick the number where you're sitting, you're just as likely to be sitting on the 5th person as you aren't. What about simple random sample, though? Would that be a simple random sample? I quite no, is what I hear over here. Why not? Who was it that said no? You were right. Was that you, Michaela? No? Look at it, that wasn't me.
Well, because you can't get every group and every group is possible.
Because you can't get every possible group. If I'm picking every 5th person, and she happens to be number 5, Christiana can't be in her group because she's not going to be number 5 because she happens to be sitting right behind her. There's no way to get a group, say, of everybody in this row. So every possible group. Yes, every person could end up being the 5th, but not every group could be because you're already all sitting down. So by going systematically, you can't make it simple random sample. Convenience sampling. Selecting data that's easy to obtain. So I need a group of 4. I've just decided that I'm taking these 4 people right up in front because they're the closest to me and I can hand the papers quicker. That's a convenience sample. I picked these 4. It was easy. It was whatever was convenient. When people send out surveys, not only is it a self-selected sample like we talked about last time, it's also convenient. I'll just take whatever information I get. Most of the time, people use convenience samples, but statistically, they really aren't very accurate because you're just using what's convenient. If I was trying to survey LMC students in general, the whole population of LMC students, I might choose you guys as my sample because it's convenient for me. You're here in this room and I'm talking to you. But do you represent all LMC students? No. No. I mean, you guys are actually very similar in so many ways. You take classes in Brentwood, not all LMC students do. You are eligible to be in statistics, not LMC students are. You are able to take classes in the mornings, not everybody is. So there's all these things that you have in common. You're all enrolled in my class, not everybody is. So there's all these things you have in common that the general population doesn't. So that's just a convenience sample. I could find out, the average GPA in this room, but it shouldn't necessarily represent the whole population because you are all a different group. You don't randomly select or represent everyone. So convenience sampling is what happens most often, but is the least telling in terms of reality. The goal is to always have a simple random sample or something close to it, but it's very hard to do. Stratified. Stratified sampling is when you divide into groups that share some characteristic. Doesn't really matter what the characteristic is. I could divide you into groups by rows like I did earlier. I could divide you into groups by last name. Just take the first 4 people on my roster, the next 4 people on my roster. I could put you into groups by height, you know, or by where you live, anything you want. And then, so you divide it into smaller groups, and then a sample is drawn from each group. So let me talk about this because the next one's going to sound similar again. So for the sake of ease, I'm going to say I divided you into groups again by rows. And I'm going to select one person from each row to be in my sample. So I'm going to come over here and I'm going to flip a coin or roll some dice and pick one of these ladies over here. I'm going to pick one from this row, one from this row, and so forth. That's called stratified. I have some groups of whatever the groups might be, and I picked some or one or more from each. That's stratified. Now, is that random? Especially if my groups are exactly the way you're sitting today. So these are how the groups are. I've got this first row has 3 people, 4 people, 5 people. And I'm going to pick one out of each row. Does every person here have the same chance of being selected? If I'm choosing one from each row.
Yeah?
Yes?
It's not assigned seating. So.
It's not assigned seating. Okay, so let's talk about it. I'm going to come over here to your row. I'm going to pick one of you. What's the chances that I get her?
1 to 3.
1 out of 3 is her chance of being in my group. What about her?
1 out of 4.
Uh-oh. She's got a 1 out of 4 chance of being selected. Do they have the same chance of being selected? That's not random then. Remember, every individual has to have the same
You get
chance?
2 groups, right?
Say that
You
again?
get 2 groups.
Right. I have 2 different groups that aren't the same size, so you don't have the same chance.
So there's 2 criteria, whatever.
Well, I don't know if it's 2 criteria. It's that the groups are not the same size, which affects the chances of being selected. If we went back to my earlier example where I said pretend there were 4 in each, if there really were 4 in each row, everyone would have the same chance of being selected. Everyone would have a 1 out of 4 chance of being selected. So it's really just, does everyone have the same chance? It's more the issue here when I ask if it's random. But because my rows are not evenly, you guys aren't evenly spread out, these ladies over here, they're in luck. They have a 1 in 2 chance of being selected. They're much likely to be in my group than anybody else. Well, you guys too, because Nick could be in your group. So that's what stratified is. You divide it into groups and take some from each group. Yes, ma'am.
And the groups don't have to be like even, because it's saying like you could do it by age, gender, income, so it's going to leave lots of like.
Oh, right. They do this all the time, especially when they're taking like polling results or by counties. There's some counties in the state of California that are much bigger than other, and they take some people from each county. It's not really representative because, you know, Contra Costa County has so many more people than, you know, Humboldt County. We have hardly any people up there. So the groups don't have to be the same size and nothing. So they're taking some from each, which automatically, unless the group happen to be the same size, it won't be random. It happens all the time with the states of the United States. If you take some people from each state, you guys do not have the same chance of being selected as people from Alaska. There's a lot less people in Alaska than in California. So the chances of you being chosen out of California is much different than somebody in Alaska being chosen because there's so fewer people out there. But they still would be doing a stratified selection by taking some out of each group if they divided us by states. Now, read cluster, and we'll talk about the similarities and differences compared to stratified. Who wants to tell me the difference? Yes? Go ahead.
Well, there's divided into groups, stratified, you're divided into groups and one person's chosen from that group. Whereas a cluster, you're put into clusters and the cluster's chosen rather than the individuals in the cluster, right?
So let's say it again. So they both are groups. It's confusing because one says groups, the other one says sections or clusters. It's groups. There's groups in the first one, a section or a cluster is another group. So they both divide people into groups. Stratified that we just talked about takes one or more. We could take 2 out of every group if we wanted. We take some from each group. So if I wanted to take 2 out of here, 2 out of here, 2 out of here, I could do that. That would be stratified. But cluster divides you into groups. Let's keep you in the same groups I have you in. And then randomly picks the entire groups. Like I might roll my dice again and say I want everybody in this row, everybody in that row, and everybody in that row. You take the entire group. That's what makes it cluster. So you're taking this large chunk, but you guys are tied together forever. If I pick him, that means I got all of you because you're all in that one group. So stratified is some from each group, and cluster is some entire groups, but not all of them. Lots of vocabulary the first week. We'll start doing some math eventually, and then you might wish for the vocabulary again, I don't know. By the way, I'm never going to quiz you on definitions. But I'm going to ask you to recognize, is this cluster or is this stratified? Is this discrete or is it continuous? That kind of thing. Questions on the differences between those two? And then finally, multi-stage is some combination of those ones up above that we just talked about. So maybe you're going to divide into cluster and you're going to take some from, or excuse me, you're going to do stratified. And you divide into groups and you're going to take some from each, but the way you're going to take some from each is systematically. So now that I put you in the groups, I'm going to take every other person. Right? That would be a combination of systematic and stratified. That would make it multi-stage. Lots of different ways. You think statistics is all about numbers, but a lot of it is how do you get your group, your sample to begin with, to not have any bias, to make sure that you represent the population so that now you can actually answer all your questions. Questions from here? Okay, so here's where we are. We're done early. Mark this on your calendar. It very rarely happens. But we're done early today. I'll hang around for the next half hour if you want to start. For those of you who have my handout, I have a question. I do not collect the lab. I just give you the quizzes on the lab. So if you want to make sure it's right, talk to me in my office hour or my lab hour. For right now, if you want to hang around and start working on the 1-2 and 1-3 lab, this is what your quiz will be on Monday. I'll stay here. I'll be going to the lab after that at 11 if you want to join me in the lab. If you have any questions about the online homework, we can do that as well. If not, I'll see you on Monday.